Today we're here with my Vanquish VS410 Pro, and on today's video what we're going to be doing is installing the Vanquish VFD Hurtz Dig. Now if you're not familiar with what a dig is, what it allows you to do is disconnect the power being transmitted to the rear axle. It will allow you to continue to apply power to the front axle, but it gives you two options on control for the rear axle. The VFD Dig is a 3-position dig unit. This allows you to have it in the 4-wheel drive position where power is equally distributed to both the front and rear axles. The center position is a freewheel position for the rear axle while the front still has power to it. This has multiple applications while crawling, both on the trail or in competition. Now you can freewheel the rear. Oftentimes when you're at steep angles and you're applying power to the rear, it will want to gain most of the traction and flip your vehicle over. You can disconnect the rear, let it freewheel, but let the front tires keep working to pull you forward. So that if you want to climb something without the rear wheels wanting to flip the truck over, this is oftentimes a proper place to use that. And the third option is the locked rear axle option. So when the dig is in the furthest most rearward position, it actually locks the rear axle while still allowing power to the front. This is very handy in being able to turn the vehicle around almost within its own wheelbase. You can also use this again for climbing like the previous situation that we discussed. And this allows you just to really get the front tires in there and biting. And then once they really get a good grip, you can re-engage 4-wheel drive and oftentimes the vehicle will just climb right up over an obstacle. Now a dig unit is a very powerful tool to have. And like I said, it's very useful both on the trail and in competition. I actually really enjoy having a dig when I'm on the trail. It's something I use constantly. And one thing is that a dig that is designed well can really function just beautifully and smooth without any hiccups, and it's just a constant thing that you know is always going to be there when you select it on your radio. Less optimal dig units can make you come completely off the throttle or even have to reverse slightly to get them to disengage, and that makes it almost pointless to have. If you can't just have a fluid transition from 4-wheel drive to locked or freewheel, then it's something that is going to be almost a hindrance to you rather than a tool. In today's video, I'm specifically going through the installation of the VFD Dig into the VFD transmission that I've got in my VS410 Pro here. This dig unit is compatible with any of the VFD transmissions, either in the vehicle kits or the transmission kit. So you can follow the step-by-step instructions in this video to find out how to install it. I'll have a follow-up video later showing you exactly some of the situations where a dig can be extremely helpful and ways that you may be able to use it that you maybe didn't think of in the first place. But for that information, make sure to subscribe to the channel so you don't miss those updates. But for now, let's jump into the installation. So here we have my chassis in the stock configuration, or at least the stock configuration that I've been running. You will see that I don't have the large battery plate that goes across the back portion of this because normally I run a smaller pack over here on the side. Now, if you did have the larger battery tray in the back there, you would just need to remove the 4 screws that hold it on the sliders, as well as the 4 screws that tie into the rear servo mount here. Pretty simple as far as disassembly goes. So if you need to complete that step, make sure that you do that at this point. Now, for my first step, what I'm going to do is start by removing the transmission from the vehicle. We need to pull the 2 screws that hold the front motor cover and motor plate into the chassis, followed by the 3 pieces of hardware that hold the transfer case to the skid plate. And finally, we have the screw that ties into the motor plate from the bottom side of the skid. At this point now, we're going to be able to pull the entire transmission out of the vehicle. My motor is direct soldered to my ESC, so I'm going to remove the motor screws from the front side of the motor plate, and we need to remove the pinion from the motor shaft as the stock 15-tooth pinion will not pull through the opening. So now we've got our transmission here outside of the vehicle. I'm going to start by removing the rear drive shaft. I'm going to pull the front drive shaft as well, just so that I don't have it moving around during video. Next, we're going to remove the 3 screws that hold the back half of the transfer case in place. With those 3 pieces of hardware removed, we can now separate the back half of the transfer case. My bearing plate and all of the gears stayed in place. I do have one bearing from the back side of the tail housing of the transfer case. I'm going to remove that. We're not going to need this plastic part anymore, so we can set it aside. Just doing a quick visual inspection, all of our gears look good, so I don't think I'm going to take apart everything and re-grease it or anything like that. All my bearings still look to be in good shape. I don't really have any concerns anywhere. So we're going to pull off this rear bearing plate and all of the bearings, trying to keep everything in place while we do so. So we've got the bearing plate off. We're going to remove all 4 bearings. And then we need to pull out the shaft that's attached to the gear that powers the rear drive shaft. That's the one that we need to look at first. At this point, we need to remove this gear from this shaft, take the pin out of that shaft, and then put this shaft to the side. At this point, we need to take that gear that we just removed and make sure that it's flipped over so that this pin slot on the back side of the gear is now facing outwards towards the back side of the transmission. Then we need to start replacing the bearing plate and all of the bearings. Now there is no shaft for that rear output just yet. So we're going to replace the 3 bearings that go in first with that final gear just resting in there, no bearing yet. Now, with the assembly done to this point, we need to install the new rear half of the transfer case first. So slide it over this assembly. And then you need to replace the upper right-hand screw and the bottom screw with the existing hardware that you removed from the stock transfer case. At this point, we still don't have the rear bearing or the shaft in place. Then you need to locate this shaft included with the new dig. We need to place on that 5x11 bearing over the shaft first. Then we're going to replace this M2x10 pin that we removed from the original shaft, and we're going to place it onto this new dig output shaft. The output shaft assembly should look like this, with the shaft, a pin, and a bearing in place. The pin holding the bearing so that it can't come off. With your output shaft in this state, we're now ready to attach the drive dog to this. Align the threaded hole of the drive dog to the hole in this output shaft. Make sure to apply a small amount of Loctite to the provided set pin and secure the drive dog to the new output shaft. Now we're ready to install this assembled rear output shaft into the transmission. Once we've got to this point, now we're ready to install that new rear output shaft. You'll need to align the pin of this output shaft to the slot in the gear. When it's assembled, it should look like this. You'll notice that the head of that set pin shaft is partially covered by the new rear half of the transfer case. The rear portion of the dig assembly will come pre-assembled. So at this point, we can align the male side of this output shaft with the female side of the dig output shaft. Then we're going to reuse the 30mm screw that we removed in the earlier steps and fasten that dig housing to the transfer case. So at this point, the transmission side of the assembly is complete. We're going to set it aside and we need to start prepping some of our electronics. For a shift servo, I'm going to be using the Tekin T120. A dig servo doesn't need to be all that powerful. This is only around 120 ounce-inches of power, so this is the one that I'm going to choose. Even a pretty basic servo will work, but it is nice to have some speed so that you can get those fast dig shifts done. I'm going to power the truck up and plug in my new dig servo. The reason that I wanted to plug the truck in is that I wanted to ensure that I had the radio at the center point of its travel so that I could take and install my servo horn with it exactly where I want. This dig is designed to work with a 24mm servo horn. You want to install the servo horn as in line with the body of the servo as you can. You're likely going to have it off just a little bit to one side or the other. We can adjust that position with the sub trim, but for now we just want to get it as close to centered as possible. So with the servo horn installed now, I can unplug the truck. I don't need it powered up for these next steps yet. This dig comes with a stainless steel shift linkage as well as rod ends to go on both sides, so we need to get that installed. There's a 1-to-1 diagram on the instructions just to confirm that you have this set to the proper length. So with the linkage assembled with the rod ends and the pivot balls in place, we can set this aside for now. Now, as I mentioned, I have already removed the rear battery plate as I typically run smaller packs on the side. If you have this in place still, you need to remove the 4 screws that hold that plate to this rear battery tray. we need to reinstall the transmission into the chassis. So I'm going to reset my gear mesh, get the motor mounted, and then we're going to drop this in place. We got the gear mesh on our motor reset, and now I'm going to reinstall the transmission into the vehicle using the factory hardware. We replaced the 2 front screws with the 2 longer pieces of hardware, the 3 shorter cap head screws, attach the transfer case to the skid plate. And lastly, we need to install the final screw from the bottom side of the skid plate into the motor plate. Since I removed the front drive shaft, I need to reinstall that now. At this point, we need to attach the shift linkage to the servo horn on that servo. I'm using the included button head screw for this just because clearances can get tight under there. Using the Vanquish servo horn is a good idea just because it is a very low profile horn, but if you choose to use another servo horn, make sure that it is a low profile design. At this point, we're going to take the servo and install it into the chassis. We're going to flip it upside down, making sure that the linkage now is on the passenger side of the vehicle, and drop it into place. If you're using the stock battery plate, make sure that it is underneath of the servo mount at this time, and then use the included longer screws and screw them in from the top side of this servo mount down through this plate, and then you'll use a lock nut on the bottom side of this plate. That will then tie this battery tray back into the brace. For me, since I'm choosing not to install the battery tray, I'm just going to use the stock screws that we removed from the tray and screw the servo down into the servo mount. I'm choosing to use it in this fashion just for simplified maintenance. That way, if I ever want to pull this Dig servo out, I don't have to mess with the lock nuts and washers that would be on the bottom side. Finally, we're going to use the last button head screw to install the shift linkage onto the shift lever. Lastly, I'm going to reinstall that rear drive shaft, again using a little bit of Loctite on the threads of the set pin. So now the actual installation of the Dig is complete at this point, but we still have one very important thing left to do, and that's program the Dig servo. For this, I'm going to be using my Futaba radio. This is the 4PV, but almost any radio with programmable auxiliary channels should be able to do this as long as it's got 3 positions. So the first step that I'm going to do though is I'm going to go into the endpoint adjustment menu and reduce the endpoints on the 3rd channel to a very narrow portion. I'm going to go all the way down to around 10 in each direction, 10 out of 100. That way I don't risk this servo turning on and binding itself and then causing the servo to overheat and possibly burn up. So at this time I have the endpoints reduced so far that I feel I'm safe to power on the vehicle. At this point I'm going to go to the sub trim menu, and sub trim is to find the set center point of the vehicle. So at this point everything's powered up, and this servo is wanting to default to the locked position. The radio itself is not indicating that, but my sub trim is slightly off, causing this to want to move backwards. So I'm going to go into sub trim, and I'm going to adjust that until the servo shift lever is allowing these rear tires to freewheel. So I feel comfortable with this position. The shift lever seems to be centered well enough between the drive dog and the rear dog. So I think we're okay to set the rest of our positions. So I programmed a switch on my radio to be set as a 3-position switch. Depending on the radio brand that you're using, the instructions may vary. For a Futaba, I went to the dial trim button menu, set it to a 100-step switch. It's a little confusing, but that's just how Futabas are. So at this point, again, we have the endpoints on this shift servo turned way down. So activating it is not going to move it very much. It's very small amounts. So what we need to do is move the shift servo first to the 4-wheel drive position. So we need to move it forward. And then we need to start increasing our endpoint until it engages fully. Especially for 4-wheel drive, it's best to do this while applying some power to the front wheels, just so that everything finds its position and locks into place well. This engaged into four-wheel drive, then you may not have been able to see, but I kept increasing it to move forward and forward and forward until the shift arm almost touches the case. You want to make sure that it's fully engaged, and that is so that those drive dogs really mesh in together. If you don't have them very well engaged, they can kind of just sit there on the ends and they'll end up wearing those teeth out, and then you just keep getting slippage. And unless you fully get those things working together, you could have issues in the future. A well-set dig, though, shouldn't have issues. I've put tons and tons of hours on these digs without ever wearing out the parts. It's just all about making sure you've got everything set well. Now, as far as setting up the rear position, that's a little bit different. We're going to move our servo back to the neutral position first, so we can see that our rear tires are freewheeling. So I'm going to move my shift servo so it's trying to go to the locked position. Now at this point, we need to increase that end point so that it starts moving rearward, but we're going to need to spin the tires by hand because at this point, the power is already disconnected from the rear drive shaft, so there's nothing to help get things lining up. And now I'm going to sit here and increase the end points until it fully seats into that locked position. You want to make sure that you can't hear the servo straining once it's in that locked position though, because that's when you can burn them out. So mine fell into place fairly easily. I didn't have to move the tires hardly at all. They just kind of clicked right in. You want to do a visual inspection when you're setting this up, making sure that there's a small gap between the arm and the case, just to make sure that the servo is not going to be sitting there in a bind. So at this point, we've got the installation all done. I just need to get my wiring cleaned up and we'll be able to finish up this installation. And that concludes the installation of the VFD Hurtz Dig into this VS410 Pro. If you guys have any specific questions, feel free to drop them in the comments below and I'll do my best to answer them as quickly as possible. As always, thanks for watching and we'll see you on the next one.